Okay, here we go. All right, so yesterday and the day before, the last couple lessons, I should say, we have done adding rational numbers. Okay, adding rational numbers is a little bit different because we had to make sure we had a denominator that was the same when they were fractions, right? Okay, so today we transition into subtracting rational numbers. All right. Now these actually are pretty simple. When we did fractions and mixed numbers yesterday and the day before, okay, what was different about fractions and mixed numbers that you had not done before? The only thing is you had done adding fractions, you had done adding mixed numbers. What was different about these? They had what? Brooklyn? Yes, they had negative numbers, okay? So it's the same thing, okay? But the thing is, with subtraction, think back to when we did subtracting integers. Okay, what was the rule you kept in mind? Chase? Copy at opposite. And that we apply whenever it was not normal, right? Okay? And it made things easy, right? Okay, do you guys agree that adding integers, adding the fractions, all that stuff is pretty easy, right? So when we use that, when we apply that to subtracting integers, okay, it's kind of the same rule, and it makes it easy on us. Okay, let's start with a few that have the same denominators already. So if I have something like this, negative 2/5, and I'm going to subtract from that, let's say negative 4/5. Okay, again, first thing I look for is, do I have a denominator that's the same here? Yes. I do, so I'm good to go now, right? So I'm going to write all of this over 5 because that's my denominator that's the same. Okay, now I want you to write all this out first, okay? So I'm going to write negative, read this with me, negative
2 minus negative 4.
Okay, so that's negative 2 minus negative 4, okay? When I look at this problem, now you may be at a point where you're comfortable enough with copy at opposite that you can do this in your head, meaning you can write it down from what's in your head, or you can simply copy this down. If I just look, if this wasn't here, guys, if this 5 and the line was, if all I was looking at was this right here, okay, would that be normal subtraction? No. And if it's not normal subtraction, what's my rule? Copy at opposite. So I'm going to copy, huh? No, the first one is copied. It stays the same. Copy. Okay, this becomes addition, and I see what you're saying. Yeah. And what's the opposite of negative 4? 4. Okay, now this you should be able to do pretty fast. What's negative 2 plus 4? 2 over 5, and that's my final answer. Okay, you kind of see how I got to that? Okay, if you don't go the route of copy at opposite and changing these into addition, these are really tricky. Okay, but to me, how many of you thought that was difficult? That was easy, wasn't it? Okay, let's try another one. Okay, can I erase that? Okay. Let's try this one. Okay, I've got negative 7/4 minus 3/4. Okay, I'll put this in parentheses so I know it's negative. Okay, what do you think I should do? First of all, do I have a denominator that's the same? I got a 4, right? So I write that 4. So I'm good for this. All right. Negative, say it with me. Negative 7 minus 3. Is that normal subtraction? No. And if it's not normal subtraction, I should copy add opposite. So this negative 7 stays the same. This subtraction becomes addition. What's the opposite of 3? Negative 3. All of that over 4, right? Okay. So what's negative 7 plus negative 3? You owe 7, you owe 3 more. Negative 10 over 4. But I don't want to leave it like this. I want to change this into a what? Mixed number. And I can do this 2 ways, okay? I'm going to show both ways. I can simplify this to negative 5 over 2, which can then turn into what? How many 2's going to 5? 2.5. Or I can do 4 goes into 10. How many times? 2, and what's left over? 2/4, which would reduce to what? Either way, they're going to go to 2.5, negative 2.5,
So what
okay?
happens if like we did a problem like that, but we left it at -2 and 2/4? Would you give it to us, or would you kind of?
Yeah, but I want you to get in the habit of always simplifying fractions when you can.
Okay.
Yeah, always. Okay. You want to try one on your own? And then we'll move to the next part. Okay.
Next part.
Oh, yeah. Okay, try this one. Negative 5/6 minus negative 1/6. Try that one. When you get an answer, raise your hand. Lucas, you already have an answer? Holy cow, man. So, what do you notice about this?
They're both negatives.
Can I use 6? Yeah? Okay. All right. Chase. -5 minus -1. Is that normal subtraction? No. So what should I do? Over 6. So if you owe me 5 and you pay me 1, you still owe me money? How much do you owe me? $4. And because it's money you owe, it's what? Negative. Very good. So -4/6. Can I reduce this to what? Negative 2/3. Okay, good. How many of you got that one right? Easy stuff, right? Okay, now, what's next? Let's see. Tell me what's different if I have one like this. 3/7 minus -3/4. Uh-oh. What's the problem? Brooklyn? Don't have the same denominator. But that's okay, right? I can just do this. 3 minus -3 is 3 plus 3, so 9. 7 minus 4 is 3. That equals 3. Does that work? Wait, no, for sure, no. Definitely does not work, okay? Don't do that method. I have to have a denominator that's the same, right? Braden, what can I use? 28, very good. So if I do 28, okay, how did I get from 7 to 28? Times 4. And what's 3 times 4? 12. And then over here, 4 times 7. And what's -3 times 7? What kind of 21? -21. Okay. So all of this is now over 28. Is this kind of where we were on the last kind of problems we did? All right. So this is 12 minus -21 all over 28. Well, is 12 minus -21 normal subtraction? No, so what do I have to do? Copy at opposite. So copy means 12 stays the same. Subtraction becomes addition. What's the opposite of -21? Positive 21. Elliot, what is 12 plus 21? 33? Yeah, 33. You were close. 33 over 28. Can I leave this way? Luke, what's wrong with that? It's an improper fraction. E-money, how many 28s go into 33?
1 and 5.
Over
28.
28. Can I reduce this any further? No, I cannot. Okay. Do we understand what we did there? Okay. You want to try one on your own? Well, tough. Okay. Oh, sorry. Let's do one. Be happy. Okay. Try this one. -4/5 minus 1/3. -4/5 minus 1/3. One of you, 2 of you have an answer. 3 of you have an answer. Okay. Abby, what's my denominator going to need to be here? 15. Okay. Let's see here. Lily, how did I get from 5 to 15? 5 times what? times 3. So I do the same thing. What's negative 4 times 3? Kind of 12. Negative 12. Good. Okay. How did I get from 3 to 15? Elijah, 3 times what?
5.
Okay, what's 1 times 5? 1 times 5. Okay. All of this is over 15. Agreed? Is that normal subtraction? So what's my rule if it's not normal? So negative 12 plus negative 5 all over 15. What's negative 12 plus negative 5? Negative 17. Can I leave that?
No.
I'm not changing it to a positive. How many 15s are going to 17? 1. What's left over? Over? Okay, good. Easy enough? Do you want me to do one more, or are you ready to do your worksheet?